a minute, and it's at that point that you will turn it in. All right, here we go. We are studying. That's where we don't waste any time. Okay, so you have an activity. For those of you in the room, we're going to do that activity. For those of you who are remote, either at home or if you're in the gym, there is a website, and you will do it on there. But you know, it's okay. We're not here yet. So let me know if you can't see it. Those of you who are not in the room, can you see the projection on the board?
Yes.
Fantastic. Okay. So before we get into our new type of function, let's just do a nice little segue from the one function that we have investigated, one type of function that we've really delved into. So here you have a table of values. Okay? And by the end of the year, I'm going to give turn off touch, turn on and go.
You never passed it.
Huh? What? What are you saying? Yes. Okay. I don't want it to react to me. Turn off touch. So it's off. Yeah. Right? Okay. Technology. Turn this off. All right. You have a table of values. The first thing you want to do is you ask yourself, is it a function? Well, you investigate those little inputs. If they're not repeating, then there's nothing to worry about. Right? It's only if the inputs are repeating that we have to make sure they don't go to different outputs. It's a function. My next question to you will be, what kind of function is it? Well, at this point, you should be able to tell me what type of function this is. So let's discuss how we would investigate this and determine what kind of function it is. Your first reaction is to do what when you see a table of values? What do we want to look at, maybe? Do we remember? Yes. So we want to look at the first finite difference. That's the first thing you want to check. Because if the first finite difference is constant, then it's what type of function? There you go. So let's go ahead and start doing the subtraction. So 9 minus 7. 7 minus 5, 5 minus 3, and you got to check all of them because, you know, I may throw one off. Just to right? So, since this is constant, the same number, doesn't change, it's a constant first finite difference, I'm going to double check over here, and these are all 1. So, I'm good. Change of y over change of x, constant, and what does that represent? The slope. So I know my slope is 2. Change of y over change of x. Okay, change of y is 2. Change of x is 1. Okay? So you can go one step further and you can write the rule. So since I know this is linear, what is the general form for a linear function? Ax plus. Okay, standard, right? But we also have another way of writing this using the slope-intercept form of the line. What's the slope-intercept form of this line? Okay, so it is in this format that I can immediately write the rule like this. Because I know this is 2. Now, remember when we did linear regression on the calculator, it wrote it like this. So it's finding us A. Right? So I know y equals 2x, but how do I know what that b value is? When x equals 0. My output from when my input is 0 is b. My constant. So there's the equation of this line.
Yeah.
Okay? So given a table of values, hopefully your first instinct is to, well, check the function, and the second one is to do the first finite difference. If it's constant, it's linear, write me the rule. What you will do at the end of the year is I could give you a whole sheet full of tables of values, and you'll be able to tell me which of those functions I told you about earlier it is, and explain to me how you know. What do you see? What is the pattern? Comes the first finite difference, linear. Baseline over linear. We're going up, right? So what we're going to do now is a little activity, and we have to be ever so careful, okay? Since it doesn't look like we're not going to be free of contamination. We're doing this activity. Now, I'm very hesitant because, you know, I'm very paranoid about contamination, so we got to be careful. So, one time you're going to come up, you're going to clean your hands, and you're going to pick up one of these. They're clean, not sanitized. Okay? Do not eat them, they're plastic.
Oh, I thought that it was M&M.
They're colored treats. And then put your midterm down. Okay? So turn in your midterm, one at a time, get this, and then we're going to do the activity. So, if you feel comfortable and you kind of try to maintain social distance, you can work in pairs. If you don't feel comfortable, you want to stay in your little bubble, that's fine too. It is easier to do this activity in pairs, but I'm not forcing anybody. Okay? Huh? Turn in midterms, pick up one of these, and then have a seat and I'll explain it to you. Yeah, unless you want to alternate who's actually manipulating it and then get your own. Okay? And then I'll explain the game. Those of you who are online, the website to obtain the game, the online version of analogous game, it's not exactly the same. It has to do with frogs, leapfrog. Go to this website. Make sure that you have Flash, Adobe Flash. Okay, if not, you may have to send a message.
Adobe Flash is not supported anymore.
I'm sorry?
Isn't Adobe Flash not supported anymore by anything?
It's on my computer still.
Okay.
Try to go here. If you have to, you know, go to this website or Google Helm frog puzzle and see if you can access it. If not, it's okay. We'll give you the table that you will eventually get and you can go from there. But I do want to explain the game. So, are we ready? I'm going to explain the game. Sit yourself and let me explain the game. Rex, Dylan, I love you're excited, but let me explain the game. Okay, whether you're online or you're using this version, the middle square or the lily pad is empty. It starts off empty. These are separate iterations, separate rows in the table. In the first one, you have one cube on each side of opposite color. Bless you. Okay, so you're going to do the game with that. In the second one, you're going to start with 2 on either side. In the third one, you'll start with 3, etc., etc., etc. Now, the point of the game is to have whatever's on this side move over here, and whatever's on this side of the blank one move over here, whether it's the cubes or the frogs. Okay? What are the valid moves you can make? You may move forward 1 space to an empty space. Or you may jump over 1 cube of the opposite color. Or frogs. You may not move backwards. You may not jump over more than 1. Okay? Now, the reason I say it's easier to do this in pairs is as these get more complicated, you kind of forget which direction you're going. You try to move backwards, you lose count, it gets out of control. So try, if you want to try on your own, that's fine, but otherwise you might want to look and help somebody and take turns, like you move and I count, I move, you count, etc. It does get a little out of control. Now, once you do this, you are creating a table of values. What does the table represent? Number of cubes you're starting with on either side. So for the first one, you're starting with how many cubes on either side? One on either side. This is the number of moves it takes to get them in the opposite position. So how many moves is it going to take? 1, 2, 3. Okay? Then the next one you're starting with 2. Then 3. What is the minimum? There's only one right answer if you're doing the correct appropriate move. Okay? Once you get up to 4, Therefore, you should be able to maybe look at the table and find a pattern and try to come up with the rule. If you think you have the right number, I'm happy to look at it and say, no, you don't have the right number. Move on. Next. If you don't, no, right here, right? Once we have put in maybe 10 minutes or so to try to get this, I will give you these numbers and then I'll give you a little push on how to get the rule if you can't find the rule. Okay, so this is what we're doing right now. So this is where you're able to look at somebody's stuff to see the problem. Yeah, I have a blank copy of this test, so if you need one day in tutorial, you can use it. Okay. Be careful. Okay, we're doing the activity, right?
So I don't think it matters as long
We only have about 10 or 15 minutes. I record you.
Okay. So. Like this? Okay. So now I don't remember what you said. I'm on you.
Yes. Don't guess.
Oh, yeah. Yeah.
Okay. Yeah, obviously when you come into a shuttle, it's when you do the same part, color next to each other. So maybe as you're doing it, always remind yourself, alternating colors. How am I going to get alternating colors next to each other? That's a huge hint. So as you do it, say, okay, what has to be next to this? What do I need to make that happen? Okay, it's looking like everybody got the second one. You cannot go backwards.
Yeah.
Oh, where's the break? right now. Where did it go wrong? What did it do? See what? You know,
When you see these four right here, and jump.
so because you have to have alternating colors,
Right.
right? So maybe as you're making each step, ask yourself, how do I maintain alternating colors? Which one has to move where?
Oh, so like,
So that you can jump. Yeah, so there's no rule saying yes.
okay.
So as soon as you make a move to where you have two of the same color next to each other, that's the problem.
Okay.
So at every step, consciously ask yourself, I need to maintain alternating colors so I can jump over.
Yeah. Doesn't matter.
Alternating colors.
Yeah.
Oh, yeah. Yes, you did.
I.
Oh, yeah.
3, 4. I don't know. She said alternate, like the two minutes. I'm not sure. Maybe. And then that one too, and then.
Yeah, so what maybe you move instead to maintain alternating color?
Is this probably correct?
There you go.
And then maybe the red. That was 5. That was 5. So now red.
And then look what's gonna happen. Alternating colors. Alternating colors. There you go.
And then you pop over. That's 6, 7.
Alternating colors. Yes, yes, yes. Bring them home. Bring them home now. Bring them home. Bring them home.
12.
Bring them home.
13. 14.
And that would be correct.
Oh, scary.
Excellent. Okay, it's looking like you got what happens when there's 3 cubes, right? We still need to do that check. Keep alternating colors. Alternating colors.
Okay, can I try on mine? Yep. Okay, so now we're going to do more.
Okay, now, you have a table. Finish the table. 5 minutes. You have to tell me what it is. After I write it out. And number 3, you should be able to get 15 moves with 3 of the same color on either side. Once you get up to 4, find you that rule. Get it? That's okay.
Okay.
I mean, this is supposed to help you get to register them. The key to this is you just make sure you alternate every using the first one. Make sure that you're consistent alternating
5.
There you go.
and then there's
5.
Once you figure out the second one, use that to figure out the rest of it.
Yeah.
If you're stuck on the third one, then you like.
Finding the rule. Why equals what? And then you take a napkin and wipe them all off.
Start with this right on this side, so.
Yes. Yes.
Yeah, I started with my own side.
Okay, will you, get a whitey and whitey, you know,
Yeah.
you know what I'm saying. There you go.
9, 10. Hey, that's all right. I think I just did it wrong.
Did you start with the right color?
right? I'm not aware. Okay, hold on, I'm gonna start exactly.
Well, I mean, whatever you think is makes them sanitary, right? If you want to pick them up and go, you know, whatever you think. Yeah, whatever.
Don't
You
hit
think.
the what?
No, but they haven't got the rule yet. Nobody's got the rule.
Oh.
Nobody's got the rule. Wait, I got the rule. Y equals. I'm looking for a y equals something X something. Oh, I have to write that rule. Yes. Oh, okay. Okay, once you finish with the cube, please sanitize them. Get a wipe, sanitize the cube, put it back in the cup. I'm looking for the rule. Keep them alternating. Keep them. What needs to be next to that green one?
A red. 7.
What needs to be next to that red one?
10.
We can make sure that our numbers are correct.
13.
Yes.
17. 18.
Okay, it's looking like most of you found it. Okay, so from this table of values, I want you to spend another couple of minutes and try to come up with the rule. Once you finish with the cubes, though, please sanitize, put it back in the cup, put the cup back on the table. Right, did you see the time? Stand down and get with the white so like maybe whatever you think is going to work, like make them sanitary. Here they are. Did you get them? Yeah. Okay, find me the rule. Find me the rule. Find me the rule. Some of you may get it, some of you may not.
Yeah.
But I love that you're trying. That's the whole point of it. I don't really expect until I show them the next. I think I got one. Oh, really? Let me see. Is that linear? Is that linear? Is that how those
How would that make sense in the first
Oh, no, but you see the pattern, but you're not seeing it the way I want you.
Okay. Okay.
I love how you see there's a pattern. But you know it's not linear, right?
Yes. Is it not linear because those are all
Exactly right.
Okay, that makes
exactly right.
So if it was like 1 and then 2, all 2s, then it's linear. Okay.
Got it. If it's not linear, will it have like different things? Well, I'm not gonna tell you, that's what you try.
Yeah.
I know that's the hard, that's the trick. Ask yourself, Dylan, what am I doing to that input value to get the output? You may not see it until I show you where it's there. But that's what one problem we're kind of going, I don't know what right now. Yeah, I see.
Wait. Oh, plus.
Yeah. What happened to the cube? Oh, yeah. Go back. Sanitize it with the cup. Put the cubes back.
Okay.
Lucy and Lydia, put the sanitizer.
Okay.
All right, I'd like to talk and give you a hint.
No. You want to figure it out by yourself.
Let's go plus.
Insert perspectives.
Okay, well, all
Bunch and I are on the right path.
right. All right. They're close. They're not close. You got one component of it correct. Yeah, yeah. Oh. I did that. It doesn't have to be. Can I ask you this question? Does this table of values represent a linear function? How do you know? Because you're calculating.
Oh, you tricked us?
No, I didn't trick you. It's not a trick. Well, I didn't tell you what it was, but that's not a trick. Okay, I know it's not linear because if I calculate the first finite difference, these values should be the same. It should be constant. If I perform the subtraction, can you tell me what the values are for the first finite difference? This minus this? No. Try again. 9. This minus this? This minus this? Okay. If those have been constant and this change has been constant, it would be linear. It is not linear. Right? Because the first finite difference is not constant. I'm not going to tell you, but perhaps. What if I calculate the second finite difference? Right? I subtract again. What do I get? So I now have, and this is important. First finite difference is constant, it's linear. Second finite difference is constant, which implies it is quadratic. Okay? Second finite difference is constant, it is a quadratic function. Okay? Now, let's talk about what the general form for a quadratic function is. Y equals. Okay, so for linear, we said ax plus by plus c equals 0, right? The highest exponent of x is 1, it's linear. What is the quadratic equation? With me. Right? Linear, the highest degree of x is 1. Quadratic, the highest degree of x is 2. Actually, let me do 300. Right? So for quadratic, it was this. For linear, it was this. That might be easier for you to see. Highest degree of x is 1, it's linear. Highest degree of x is 2, it's quadratic. Are we all on the same page? Yes? This is linear. This is quadratic. Now, when we had a first finite difference that was constant, that first finite difference was your slope. The b, the constant, was the y value for the y-intercept. If I am now looking at quadratic equation, I can calculate a constant finite difference, but what is that in the equation? You don't know, right? I know it's quadratic because this is constant. Well, how does that help me find the rule? I'm going to drive that. Okay? So if you look at this sheet, this is the sheet that is going to allow you to determine what this is in terms of your equation. So for example, I am beginning with this standard form for quadratic equation because I've already told you, we already recognize it's quadratic because I had a concentrated finite. So to find the rule, we needed to figure out what that second finite difference represented. To do that, we go back to the general form and we go ahead and let x equal 0, let x equal 1, let x equal 2, find the finite differences, and this is going to tell me what this represents. It's a divider. You don't ever have to memorize it because you can always read your writing. So if I go back in here and I say, all right, I'm coming here and I'm letting x equal 0. So that means I have a times 0 squared plus b times 0 because I'm saying let x equal 0. Simplify. Anything times 0 is 0, so what is this equal? All right. Now, let's go ahead and let x equal 1. A times 1 squared plus b times 1 plus c simplifies to be what? A plus b plus c. Right? Now let's do that for f of 2, f of 3, f of 4. Simplify. Once you find these, I want you to subtract. So we'll do the first one. This minus this gives me what? Okay? And then once you have this, you can do it again. And then that's going to give us the answer. So go ahead and finish this table. And you tell me. You're doing a, well, I mean, whatever. You should be able to do this one on your own. So you have to be able to do this on your own. Once you think you've substituted in correctly for each of those values of x, I've written that on the board. I have not found any finite differences. I've not found any finite differences left. You're going to tell me those. Make sure you can all get to here. Now we found the finite differences? Yeah? Okay, if I subtract this from this, what do I get? Or this from this, what do I get? This minus this. This minus this. Lastly. Okay. Now, that's the first finite difference. If these were all the same, it would be linear. So now let's do it again. Second finite difference. This minus this. Okay. So since my second finite difference is constant, we know this is quadratic. Then now you know what the second finite difference in any quadratic table of values represents. It's always 2a. So whatever number you get as your second finite difference, in this case I happen to be 2 for the shuttle. So for any quadratic function, you set that second finite difference equal to 2a, then you know a. Right? You know a. So let's go back and do that with the shuttle game. I know that this second finite difference equals 2a. You always set it equal to 2a. So what is a? Solve for a. What is a? No. What? Right? Now, ultimately, I'm trying to write this equation. I've got a little thing, nuts on the board. Okay, a is 1. I just found it. Do I know anything else? Yes. Because I set the second finite difference in the shuttle game equal to 2a, which we just derived is what the second finite difference represents. So whatever number this is, you set it equal to 2a, you solve for a. Oh. Okay. We're doing the next table, that sheet of problems. Determine is it linear, is it quadratic, or neither, and then find the rule if it's linear or quadratic. Hear about that. Okay, so I know a is 1. I found that. By calculating the second finite difference and setting it equal to 2a, I know a. Is there anything else I know? How? It does? What does C represent? What is
Well, I
it?
guess if it's 0, then it's not
There you go. There you go. You have 0 cube, 0 root. So what is the constant? What is C? The y value of the y-intercept is 0. Right? We'll just simplify that. I'll need to see some of this stuff from here. How do I find B? How do I find B? What? How do I find B? You have a table of values, you have an equation, you have a missing value. But what do you have? What do you have a table of X and Y values? In fact, literally substitute in column 0. And substitute in 3 for Y, 1 for X, and 1 for B. No. What is B? It's 2, right? So what is the equation of the shuttle game? You see how to find that rule. So given a table of values, your first instinct, obviously after making sure it's a function, your first instinct is to find the first finite difference. If the first finite difference is constant, you know it's linear. You have the slope. So back up the table if you have to go in and do. You get the outcome. I don't know why. You don't have to. Right? Now, once you get a table of values and you determine it's not linear, maybe your next instinct would be to calculate a second finite. If that happens to be constant, it's quadratic. Set this number equal to 2a, find me a. Back up the table if you don't have an input of 0, find me the constant. And then substitute a point in the table to get me b. So guess what? Let's turn to the next page. Look what we got. Table. Table, table, table. On this page, you are to determine, is it linear? Is it quadratic? Is it neither? If it's linear, meaning you found a first finite difference, find me the rule. If it's quadratic and you found me a second finite difference, find me the rule. If it's neither, there's nothing you can do with it, you move on. You have to state that. So state whether it's linear, quadratic, neither. If it's linear or quadratic, find me the rule. You may work together, you may take your answers from each other. We're starting on Tuesday's class by going over all the rules. Seeing which ones we got, which ones we didn't get, and then we're moving on to 1.6. That's it. Okay? So you're free to work now. You're welcome. Any questions online? No questions?
No.
Okay, there you have it. So you're.
Oh, I have a question.
Yes.
How come in the grade book it doesn't actually say my grade? It just has.
Oh, because as soon as I get the question asking me how they can get 0.3 or 0.3 of a point, I removed all the grades because I wasn't going to play that game. So I will put those back.
Okay, thanks.
Absolutely, yes, I will put those back. I just wasn't going to, were y'all happy with your grades, your midterm grades? Okay. You could have been happier, is what you're saying. Okay. All right, yeah, I'll put those back.